In today's lecture, we are trying to find slant asymptotes. Last week we talked about the vertical asymptote and then the horizontal asymptote. And to find the vertical asymptote, we usually use the domain of the function, right, which is the denominator. Yeah. And to find the horizontal asymptote, we look at the numerators and the denominator, right? Yeah. Now, you notice that in this case, the denominator is x, and the numerator, the highest degree in the denominator is 1, right, which is x to the power of 1. And then the highest degree in the numerator is x to the power of 2, right?
Wait, so how do we, because there's two 2's here, how come it's not?
Well, I'll take the one with the highest degree, right? Degree means when you look at this, like 3x squared minus 2x plus 2, right? Mm-hmm. The variable with the highest number is what? X squared, right?
Yeah.
And in the denominator, the one with the highest is x, and the degree is 1. Mm-hmm. That's the highest power this denominator has here, x to the 1, right? All right. Now, whenever you have this type of function where the degree in the denominator is less than the degree in the numerator, when you compare the highest, you know that there is possibility of a slant asymptote, okay? And to find the slant asymptote, we do the long division. We're going to divide this fraction here. So let's pull this aside, and we're going to divide that on a piece of paper. So read me the function again.
It's f of x equals, for the denominator is 3x squared minus 2x plus 2, and then divided by x minus 1.
X minus 1. So remember, the first thing is this degree, right? Of the new denominator is 1, right? Because x to the power of 1, okay? And the numerator is x squared, right? Degree is 2, right? So since the degree in the numerator is higher than the denominator, you know that there is a slant asymptote. So we're going to find it. So we're going to do our division. Have you ever done a long division before?
Yeah.
You forgot?
It'll come back to me as we do.
So let's set it up. So it's going to be x minus 1 here. You can hold the paper down a little bit. Thank you. X minus 1. And then we have on top 3x squared minus 2x plus, you can remove your finger for 1 second too, right? Okay, and this is how I'm going to do. I'm sorry.
I've done long division, but not this many variables.
I didn't set it up the right way. That should be in the bottom here. I don't know what I was thinking. If you're watching this, disregard what I just did here. That was the worst thing I could have done. 3x squared.
You had an elite game moment.
Yeah. No, you're smart. Don't say that. Okay, yeah, you're right. Anyway, so then here's what we do. How many times can x minus 1 go into 3x squared?
1 time.
3x times, right?
Oh, wait.
Because you're taking the x here, you put it into the 3x squared. You're left with what? 3x. So 3x times x is 3x squared, right? And 3x times negative 1 is negative 3x, okay? And then we're going to do the subtraction here. That's the long division. I'm sure you learned about it.
We know it. Okay? It's just weird with all these variables. So I minus these. That's
that'll be, remove your finger, that'll be 0, right? 3x squared minus 2x, so that's 0, right? And then negative 2x minus negative 3x will be x.
Just x?
Because guess what? A negative and a negative gives you a
positive.
So that'll be 3x minus 2x. You're left with x, right? And then you bring down the 2. So this is now x plus 2, correct? Now, how many times does x goes into x? One time. Good job. So it's plus 1, okay? So 1 times x is x, right? And 1 times negative 1 is?
Well, 1 times negative 1 is 1.
Negative 1, right? Negative 1, okay? And then you do this.
Then I subtract.
X minus x, 0. 2 minus negative 1 is
1.
No, 3. 2 minus negative 1.
Yeah,
3, that's your remainder, right? Now, this piece that we have here, that will be your slant or your horizontal asymptote. So we're going to call it y equals 3x plus 1 is the horizontal asymptote. The slant or the oblique asymptote.
Wait, so when y is at 3, that's where it's going to slant?
Say again?
So like when it's at 3, that's where it's going to slant?
3x plus 1, we're going to graph it, okay? 3x plus 1. And then this is how we write it. I'm gonna show you.
So this equation I tried to find where the slant asymptote is by using long division.
Yes.
So first, I saw how many times x goes into 3x squared, and I found that it only goes into 3x times.
Good.
And then after that, I did 1. I did 1. How many times was 1?
No, when you did the 3x time, what did you set up here? Show us what you did over there.
When I got 3x, I put it down here.
But how did you get that? You did 3x times?
3x times x.
Gives you what?
3x squared.
And then 3x times?
No, I did 3x times 1.
And then -1?
-1. That gave me -3x. And but I only made a positive so I could remember.
Because you have to switch up
I have to switch up the orders of operation.
Good. You mean the signs in there?
Yeah, and then I subtracted. I subtracted this. I got 3x minus 3x squared. And I got 0. And I subtracted -2 plus 3x. And I got 1x. Then I brought down the 2.
Good.
And then I did the same thing. Where I saw how many times does x go into 1x. And it came 1 and 1 time.
1 time, good.
Yeah, and then I saw.
Do the multiplication again.
Now I did how many times 1x?
No, you did 1 times x.
Wait. Oh my.
You got here, right?
Yeah.
You did 1 times x is.
Oh yeah, 1 times x is -1.
No, it's not negative. It's 1x, right?
1x.
And then 1 times -1 is -1. And then we switched.
Oh yeah, I switched the order
because there's a imaginary negative sign here, so it has to be switched in there.
Yeah,
correct?
I switched it.
Good.
And then I did 1x minus 1x. I got 0. And I did 2 plus 1, and I got 3.
And then what's your slant asymptote?
3x plus 1.
Was that easy or what?
Yeah.
Yes, sir.
I just need to remember.
Now what we're gonna do is we're gonna try and rewrite the function given the asymptote and the divide and the dividend and the remainder. Correct?
Yes.
So this is the equation. 3x squared minus 2x plus 2, x minus 1, that's the function. And when we did our long division, we came up with this over here, right? This is the asymptote, and this is your denominator, and this is your remainder. So to rewrite this function, it's going to look like this.
So I just do this thing.
Now I'm going to write it down and you see. You can hold on the paper for me. You can hold it over there. Okay, f of x. So first thing we need is the asymptote, correct? Asymptote is 3x plus 1, correct? So it's going to be 3x plus 1. And then the remainder plus, what was the remainder?
Plus 3.
3 over the denominator, x minus 1. And this is how this function decomposed would look like. Okay? So this is your asymptote, and this is your remainder, and this is your denominator. So we're going to write this. This is asymptote, or slant asymptote, right? And this is your denominator, right? And this is your remainder. So this is how you break down the function once you're done. And this is going to be your asymptote here, correct? Got it? The next thing we want to do is we want to find the limit as x approaches negative infinity and positive infinity, right? So we have the function, and what we need to do is just break it down into this here. We have limit of the entire function, which is 3x squared and negative 2x plus 2 and x minus 1. We talked about simple rational function last week, and what we do is we figure out the coefficient with the highest degree over here, right? Which is in this case is 3x squared. I shouldn't use coefficient, I mean the variable in this case. And we do the same thing with the denominator, which is x. So 3x squared by x, we get to this point. And as our x approaches negative infinity, what's going to happen to the term? It's going to go to negative infinity. So this is going to be negative infinity. Same thing with the positive side. So this is how you find the limit. You take the highest degree on the numerator and the highest degree in the denominator, and then you find the limit of the function as x varies from negative infinity to positive infinity. All right. Last step to graph the function is we need to figure out we need to draw the asymptotes, and then get the x and y intercept, and then we can go ahead and draw the function. But the first thing, the one thing that we were missing was the vertical asymptote. And to find the vertical asymptote, we have to look at the denominator. We worked on that last week. So we have to set it up this way, and x cannot equal 1. So x equals 1 will be your vertical asymptote. And then the next thing is graphing the slant. And we chose some random point, And when x is 0, y will be 1. We just plug it in here. When x is 1, y will be 4. So we drew that over here, this length. So when x is 0, y is 1. When x is 1, y is 4. And then we draw it as a dotted line. And then the other thing will be to draw the vertical asymptote, which is x equals 1 right here. We just plug 1 and draw a vertical line. And then the last step is we found y-intercept in this case. When x is 0, y will be -2. Now to find the x-intercept, we have to use the quadratic formula. We don't, and I'm not going to use that because I was going to factor this function, but it's not factorable, so we have to use the quadratic. But once you have this, it's pretty much a done deal. You can draw your function given your asymptote and your vertical asymptote and your slant. So the function is going to look something like this. It's going to go through -1, and it's going to be symmetric over here. So this is the function. Make sense?
Yeah.
Okay, now we're going to work on the next one.